special case equations and inequalities. We're talking about solving special cases and what exactly do they mean. Okay, so these first two are the two different examples we're going to talk about. So the first example is considered a no solution example, as in we solved it and there is no solution. Okay, now how do we know that beforehand? You don't. So what you have to do is you actually have to solve it like you would normally do. Okay, so first step, draw your line, right? Then you ask yourself, on the left-hand side, is there anything to distribute or combine? Yes, I need to distribute. I got to get rid of that parentheses first. So I'm going to go ahead and distribute to the parentheses. So that will give me negative 8x minus 4 equals negative 8x minus 2 on the right-hand side. Now, on that right-hand side, is there anything to simplify or distribute or anything like that? No, okay, so now I can go ahead into my solving process. Now, when we solve equations, we need to make sure all variables are on one side of the equal sign. And in order to do that, Coach Kimball told you that mathematicians like the variables on what side? The left side, okay? So that means I want to take this right here and get it over to this side. Now, how do you move something from one side of the equal sign to the other? Subtract or add, okay? In this situation, am I going to subtract or add? Add, perfect, okay? So I got plus 8x plus 8x, all right? This will cancel, and I'm left with negative 2 equals, okay, negative 8x plus 8x. Wait a second, doesn't that give you 0? Yes, that cancels out, which is okay. If you cancel out all your variables, you must now think of one question and one question only. Is my statement that I have true? Is negative 4 equal to negative 2? Do those equal each other? No, this is a false statement. Now, once you eliminate all your variables and you look at your statement and it is false, your answer now is no solution. Which means there is no possible number that could work as a solution to the equation. There is no number that you can do that will give you an answer. So that's an example of no solution. When your statement is false, you have no solution, okay? Infinitely many solutions, okay? Here's an example. Same process. Looking at the left-hand side, because I like to read it like a book. Is there anything to combine or distribute? No, okay? So let's look on the right-hand side. Is there anything to combine or distribute? Yes, I need to distribute. So I have 3 minus 9x minus 8, negative 5 minus 9x, okay? Still looking at it. Is there anything I need to combine? What do I need to combine? Negative 8 and 3, which gives me what? Negative 5 minus 9x, because I haven't done anything to that there. And then I have negative 5 minus 9x. All right? Once we have combined and distributed all possibilities, okay, I now need to get all my variables to one side. And what side do we prefer? The left. So I need to get this to over here. So I will do the opposite. Remember, the only way you can move something left to right is by adding or subtracting. And what that does is I'm left with negative 5 on this side. Okay. Oh, same situation. I eliminated all my variables, and I'm left with negative 5 on this side. Now, is this statement true? Yes, this is a true statement. Now, when you get a true statement, your answer is not infinite solutions. It is all real numbers. Now, instead of having to write all real numbers, mathematicians, because they like to be fancy pantses, created a symbol. That symbol is you start with the number 11, I'm telling you how to draw the symbol. You start with the number 11. Then you take this one right here to the very top. Take your pen on the top. Curl it around like you're going to draw a P, but you're going to stop it on the second one. And then turn it into an R. This is the symbol for all real numbers. So again, you start with 11. Right here, you create an R, but when you do the loop, you stop at the second one, and then you just finish the R. Does everyone understand how to do the all real number symbol? Sweet. Okay, so this would be my answer. All right, I'm going to go to questions 3 and 4, okay, because those gave us equation examples. I now want to talk about inequality examples, okay? So, first things first, I'm the realist. Anyone catch that? No? Okay. Left-hand side, do I need to distribute or combine like terms? Yes, I need to distribute. So I will distribute 12x. Okay, so I distributed the first one, distribute to the second one, negative 36. I have a greater than sign. Oh, I need to distribute on the right-hand side also. That gives me positive 12x. Negative times a positive is a negative, and then 4 times 3 is 12. Okay, do I have any like terms to combine on this side? No. Do I have any like terms to combine on this side? No. No, I do not. Okay. So now, mathematicians say, get all my variables to the left-hand side because it's pretty and we read from left to right. That's why. All right, so I'm going to get my variables to one-hand side, and to move variables from one side to the other, I add and or subtract. This cancels, and I'm left with negative 12. This also cancels. Oh, look at that. Bring this down, and I have negative 36. Now that all variables have been canceled, you ask yourself the same question. Is my statement true or false? Is negative 36 greater than negative 12? Raise your hand if you say no. Raise your hand if you say yes. Raise your hand if you don't care. Wave around in the air. Or you just don't care. No? Okay. The statement is false. Negative 36 is not greater than negative 12. Now, if they were both positive numbers, that would be a true statement. But this is false. So anytime you have a false statement, my answer is no solution. And look what I'm putting. NS. Shorthand it. NS. No solution. Bingo, bango, bongo. I guess. Make sure you take the pass with you. Where's the water or the pass? Which one? I can answer both questions. Pass is right there. Remember, the water fountain's just like right there. All right. Looking over here. Okay, looking over here. Same thing. Draw your line. Do I need to distribute over here? No. Do I need to distribute over here? Yes, big time. I actually have two separate distributions I got to take care of. Distribute, 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 distribute. So I'll distribute that one through. 7x plus 14, negative 4x plus 28, because a negative times a negative is a positive. And then nothing was changed on this side. I've distributed. Do I need to combine like terms? Yes. Combines. What's 7 minus 4? 3x. What's 14 plus 28? Just read my paper. 42. Okay. Once I have distributed and combined all like terms, I can now solve by getting all my variables to the left-hand side. So minus 3, cancels, negative 13 is less than or equal to 42. Is this statement true or false? False is incorrect. Is 42 bigger than negative 13? Yes, so it is a true statement. Now, if your statement is true, our answer is all real numbers. All real numbers. Yes. No. What a terrible, horrible, no good, very bad question. Just kidding. Yes, absolutely. Go ahead. Sarcasm. Questions, comments, concerns on the first page of notes. Yay. Turn to the page. So now what we're going to talk about is called literal equations. Literal equation. Literal equations are still equations, except instead of having all numbers, I'll have multiple different variables in there. Okay? But the steps and process to solve is still the same. Okay? So here's my first example here. Okay? Looking at this first example, what would y'all think is my first step after drawing my line? Add 5. Perfect. Plus 5. Good. That gives me 18. Okay? Now, again, looking at this process, what would I do next? By 2. Simple stuff, right? All right? However, look at problem number 2. What? It's nothing but letters. Coach, what are you trying to do to me? I'm trying to make you smart. Trying to make you smart. Okay? This says, in the directions, solve for what? X. So, X is my true variable. X is my true variable that we're going to solve for. Just like what we did here. We solved for X. So, I do the same steps. Draw my line. A is being multiplied to the X, so that's my coefficient, which means I need to get rid of this first. How do I get rid of a minus? Add. So, I'm going to add B to both sides. Yep, you heard me. I'm going to add B to both sides. So, where now I have A times X equals C plus B. Yep, I just wrote it for what I did. C plus B. I don't have any numbers to combine, so I just write it as C plus B. Over here, when I had a coefficient next to a variable, I divided. I also have a coefficient, in this instance, is A, so I will divide by A, to where X will equal C plus B, all of that divided by A. The process and steps in which I solve is still the same. It is still the same. What's different is I don't give you all numbers, but I give you multiple letters as well. Okay? So, similarities again. You solve the same way. Okay? And what's different is I have multiple variables. Multiple variables. We are going to do 3, 5, and do I want to do that one or that one? I'll do 7. 3, 5, and 7. Let's stick with the odds. Okay? Now, the directions say I need to solve for what variable? W. So W is my true variable. W is the true variable. Okay? What is currently happening to the W right now? Speak a little. Speak up. Speak up. You're multiplying by L, okay? So if the goal is to get W by itself and L is currently being multiplied to the W, how will I get rid of said L? Divide. So W equals A divided by L. This right here, does anyone know what equation this is? You know what we use this to solve for? Area. That's the area equation. Length times width equals area. That's just the equation for area. And all we did was solve for a missing length. So to find the missing side length, you just do area divided by one of the sides and you get W. You've been doing this all along. 4 is the exact same as 3, except instead of L and W, it's B and H. Okay, but it's literally the exact same thing. 5. Anyone recognize this equation? It's the simple interest formula. Simple interest. Now I want to solve for t, time. I want to solve for time. Time is my true variable. So if I notice P and R are both being multiplied to the t. So because they are both there connected by multiplication, I can now divide by both to both sides to where t equals my interest divided by the principal times the rate. And the only reason why I can divide by P and R at the same time is because they are both being multiplied to the same variable. Because they are both being multiplied to the same variable. Seven. I'm solving for C. C has a minus S. Okay, so how do I get rid of the minus S? I add it to where C equals M plus S. I'm still solving these the exact same way I have been. The only important thing that you need to do first is to identify what the question is saying is the true variable, which means all the other letters represent different numbers that you just don't know yet. Okay? So you need to figure out which one's the true variable, and you know that by what it says. Solve for C. C is my true variable, so I need C by itself. Turn the page. Those examples are one-step examples. So it takes just one step to solve. Okay, this back page is 2 steps. 2 steps in order to solve. Okay. So again, like I said, literal equations do have some numbers in them. It's just they have more variables with it as well. It's just not one variable, it's multiple variables. All right? So the important thing is to identify my what? Starts with a T, rhymes with true variable. True variable. Okay? What is my true variable? W. So W is what I am solving for, which means I need to get W by itself. First thing I'm going to do is I'm going to subtract 2L from both sides to get W by itself, to where P minus 2L equals 2W. I'm trying to get W by itself, so what would I do next, do you think? Say it. Perfect! I divide by 2. To where W equals P minus 2L divided by 2. This is perimeter. This is called the perimeter equation. We're not done yet. We're not done yet. All right. This one, what is my true variable? Y is my true variable, so Y is what I need to get by itself. Okay, I forgot to say draw your line first. Make sure you draw your line first. All right, first thing, okay, B is being multiplied, so I don't get rid of that first. I get rid of this first. Okay, to move this to the other side, what do? What? Minus. Okay, I will subtract AX to both sides. Then I'm left with B times Y equals my C value minus AX. Processes are still the same. The processes have not changed. We want Y by itself. I want to eventually be like this. So what do I do to get Y by itself? Divide it by this B. So Y in all is our C value minus our A value times X divided by our B value. The only difference is I don't know what C, A, and B are yet. This equation is called standard form. You will actually see this form later in the year. Questions, comments, concerns? Sorry, I had a big yawn. All right, we're going to do one more example. We're going to do number 12. Because what does number 12 have in it? A fraction, and we need practice with fractions, all right? What's my true variable first and foremost? F, okay? So F is what I need to solve for. So I'm going to draw my line, and I'm going to ask myself, do I need to distribute? Yes, I need to distribute. The 5/9 goes into both sides. So C equals 5/9 F minus, and I'm just going to help you out for time reasons. 5/9 times negative 32 is negative 160 over 9. Okay, again, I'm helping you with time restraints, so I'm just kind of giving you what that multiplication is so we can move forward. Okay, all right. So now I'm solving for F. So what do I need to do first? Add 160 over 9 to both sides. It's very simple, especially since this is just a letter. Okay, it's very simple. Watch what I do here. I now have C plus 160 over 9 equals 5/9 F. Very simple so far. Okay. Now, I'm going to ask you this very important question. How do we get rid of a fraction in equations? Multiply by the reciprocal, okay? Which reciprocal is a fancy smancy way to just say what? Flip your fraction. All it is flip your fraction. So I'm going to multiply by 9 over 5 to both sides. Multiply by 9 over 5 to both sides. Where these two fractions leave me with just F. Okay, I'm going to write it all over here. It leaves me with just F. Equals. Okay. If I multiply 9/5 to C, I get 9/5 C. Okay, so as you can see, I'm basically distributing again here. 9/5 times 160 over 9. Okay, now that's a really tough fraction problem. So what do? We grab our handy dandy calculator. Okay, how many of y'all have ever seen Blue's Clues? Remember a handy dandy notebook? Well, we have the handy dandy calculator in Coach Kimball's class. Okay, so I'm going to do alpha x, okay, which gives us the fraction bar, and I'm going to do 9 over 5. Then I'm going to do times alpha x, 160 over 9, and then I'm going to hit enter. What do I get? Positive 32. And we just solved for Fahrenheit. This is how you go from Celsius to Fahrenheit or Fahrenheit to Celsius.